Wow, AI can do almost anything now. It can write scripts and even help someone blind for 10 years see the world again. Yep, you heard me. In the UK, Sheila Irvin, 70, went completely blind from macular degeneration. What did her doctor do? Slipped a chip thinner than a hair into the back of her eye. Here's the wild part. The chip beams AI-processed images to her brain so she can see again. Even the paper's fine print? She reads it better than your grandma can. How's that possible? Have we actually built the Terminator's bionic eye? I'm Dr. Jung Ding Liang, geriatrician. Quick check for me. Have you hit subscribe yet? If you enjoy our channel, share it with your grandparents, your uncles and aunts too. Now, let's use science as our key to unlock a long, healthy life. You know what? Some people literally can't look you in the eye. Not because they're snobby. It's because their central vision is just gone. That's macular degeneration, a slow breakdown starting at the center of your eye. The macula is basically the eye's most fragile spot. It has 20 times more photoreceptors than the periphery and gets hit daily by light, oxidative stress, and metabolic load. Over time, it's like a camera sensor getting sunburned. That generates tons of lipid and protein waste. It builds up into tiny yellow pebble-like deposits. We call them drusen. These nasty deposits keep piling up into one big patch, blocking the retina, taking over your central vision, and making the immune system treat them like invaders, sparking chronic inflammation. Eventually, the eye looks like a map with a chunk torn right out, forming geographic atrophy. At this point, whatever you want to see most is always pixelated. You can only guess what's in the gaps. The scary part? This isn't some rare condition. It's actually common. In Western countries, macular degeneration is a leading cause of blindness. Studies show that past 60, 1 in 12 people starts developing it. Past 80? It shoots up to 1 in 3. Those odds are no joke. So can treatment fix it? Sadly, for now, treatment can only slow it down, not reverse it. Once your central vision goes dark, it's nearly impossible to get back. Tough luck, I know. Take 2 drugs that just hit the market, Syfove and Izervay. Both are complement inhibitors. Basically, they stop your immune system from attacking the retina by mistake. That dials down inflammation, slows cell death, and reduces progression by roughly 14% to 20%. For patients with later onset whose disease moves slowly, these can be a life-saving speed bump. But if your macula is deteriorating at breakneck speed, these drugs really can't help you. But as we know, what scientists love most is tackling the impossible. With AI booming lately, they've actually forged a new path. If damaged eyes can't be fixed, don't fix them. Just bypass the dead cells and send images through the brain's visual pathway. Solved, right? The real breakthrough is right here. Scientists found that even though macular degeneration patients have lost their photoreceptors, the layer underneath, the inner neurons, like bipolar cells and ganglion cells, the wiring that carries images to the brain, is surprisingly still intact. So they've flipped the approach. If the camera's broken, just wire around it. They built a system. In about a 2-hour surgery, a microscopic chip gets placed beneath the atrophied retina. So if it sounds this amazing, what does this chip look like? It's called Prima. Just 2 square millimeters, under 30 microns thick. Thinner than a single hair. Looks like a tiny gold flake. Think of it as an ultra-mini solar panel. Made up of hundreds of micropixels. Each pixel is a photoelectric converter. When light hits it, it turns light into tiny currents that stimulate the living nerve cells above. The best part? No battery, no wires. All its power comes from external light. The whole thing is fully wireless and passive. But hold on, the chip itself can't actually see. So how does it know what's out there? That's where the key device comes in, custom AI glasses. On the front of the glasses, there's a tiny camera that sees the world for the patient. Whatever it captures goes straight to a small computer at the waist, where an AI algorithm strips the complex scene down to dark, light, and edge outlines, signals the chip can understand. Basically, light signals. Then the computer converts those into near-infrared light signals. A tiny projector inside the glasses beams the light into the patient's eye, focusing it precisely on the Microchip. Why near-infrared light? Simple. This kind of light can pass through eye tissue without harming other cells. Safe, yet strong enough to activate every light-sensing pixel on the chip. So in these patients' brains, what they receive is no longer natural light, but artificial electrical stimulation. At first, patients can't make sense of those signals at all. All they see are tiny flashes, what we call phosphenes. So the next step is key: training patients to read those lights. Which flashes mean bright, which mean dark, slowly piecing together shapes, then outlines, and finally, words. It's like learning a whole new language. At first, you can only pick out a few letters, but as the brain gets used to this signal pattern, the picture gradually sharpens. So does this tech actually work? Is it dangerous? Relax. This isn't just a concept or some lab prototype. It's a real result from a multinational human clinical trial. In the Primavera trial, run in the UK, France, and the US, 38 patients with late-stage dry macular degeneration took part. Every single one had lost all central vision for years, so severe they couldn't even read the eye chart. The results, honestly, even stunned the research team. On average, patients improved by 0.25 logmar. In plain terms, on a standard eye chart, they could read 12 to 13 more letters. That's not just a small gain. It's a miracle, from seeing nothing to reading words again. Like Sheila Irvine we mentioned, the 70-year-old British grandma, just weeks after surgery, for the first time in years, she could read a newspaper headline. When she read that line, she teared up and said, "I can read again." This was published in the New England Journal of Medicine. After a year of follow-up, nearly 90% of patients saw improvement that remained stable. No major complications either. The research team called it a milestone in artificial vision because for the first time in humans, it proved that an electronic chip could restart central vision. Prima is impressive, but it's not magic. It can turn darkness into sight. But we're still far from seeing clearly. The first and biggest limitation, image quality still isn't good enough. What you see is more like a black and white Game Boy. You can make out letters and outlines, but facial expressions, color, and detail, still out of reach. Second, your brain has to learn a new language, artificial vision, not plug and play. It's a system you must relearn to see with. Some train for weeks, others may need months. For older patients with cognitive decline, training gets much harder. Third, cost and accessibility. It's cutting-edge implant tech. Surgery and equipment aren't cheap. And it's still in the clinical trial stage, so wide availability? Not anytime soon. And finally, not everyone qualifies for this kind of tech. If for other reasons, like diabetes or retinal detachment, the nerve cells beneath your retina have already severely degenerated or been damaged, then even if we send the signals, they still can't reach the brain. So Prima wouldn't suit you. Prima's arrival is really just the first step. Around the world, this isn't the only path. Argus, too, was the first to open that door. It was the world's first FDA and EU-approved bionic eye. Although its image quality was crude, it proved that blind people really can see light again. Some teams used thalamic electrodes to directly stimulate the visual relay, bypassing the eye and damaged retina. Even more radical is the Monash University team's cortical implant, creating dots and shapes directly in the visual cortex. Works even if your eyeballs are damaged. Neuralink and Meta are pushing even further, using AI and electrical stimulation to try painting images directly into your brain. Eyes are the windows to the soul. Vision happens in many stages, from the cornea and lens to the vitreous, photoreceptors, optic nerve, and finally the brain. If any step goes wrong, vision suffers. We've talked before about how scientists found effective new treatments for corneal damage and presbyopia. If you're interested, tap here to catch up. Want to know more about the latest eye tech? Which topic grabs you most? A. No shots, just eye drop therapy for wet macular degeneration. Or B. Autofocusing AI glasses for myopia and presbyopia. Or C. Only kids choose. I want both. You order, I cook. Drop us a comment. If you want more medical news and updates, stay tuned to our channel and don't forget to subscribe. Join Team Health and let's stay healthy together.